Here is more practice for you drawing these Haworth structures. When you are given a straight chain and you are asked to draw in the cyclic form, the first thing that I always do is draw my ring template. So the ring template is going to depend on whether you have an aldose or a ketose. If you have an aldose, which we have, then the ring will have the 6-membered shape. It's going to look like that. So I'm going to always start with that, and then I also go around my ring and draw in all of my vertical bonds like that. And the next thing that I'll usually do is number the carbons in my ring. And I remember that carbon 6 comes up and out of the ring like that. And I'll go back to my straight chain and number those carbons as well. And then I'm ready to start filling stuff in to my bonds. I got the wrong number of hydrogens there. CH2OH, so I have filled in carbon number 6, and I know carbon number 5 also has a hydrogen on it. So that, what we're looking at, that is the generic template for an aldose. They're always all going to start like this, all of them. So the next thing that I'll look at is which anomer I'm being asked to draw. This one's asking me to draw alpha, and so I know that that means at carbon number 1, my OH group needs to go down with the fish, like that. And so I've got most of this drawn. I just need to figure out carbons 2, 3, and 4. To get the right positions of the groups on carbons 2, 3, and 4, I have to go back to the straight chain molecule, carbons 2, 3, and 4, and imagine when I turn this thing clockwise to the right, where will the OH groups end up? So I'm visualizing in my head, if I turn it clockwise to the right, all of those OH groups are going to end up pointing down, and all of the H's are going to end up pointing up. So this is what we get. Let's try another one. Here is another aldose. And so that means that we are going to have a template that looks like this. And we've got our vertical bonds going around the ring like this. And we know that we're going to have CH2OH and an H like that every time. And we can number these carbons 6, 5, 4, 3, 2, 1. And we can number our straight chain 1, 2, 3, 4, 5, 6. So now we're ready to start filling this in. This one is asking us to draw the beta anomer, which means on carbon number 1, our OH group is up with the birds. And to come up with the position for carbon 2, 3, and 4, we have to look at the straight chain molecule. When we rotate this thing on its side to the right, the OH on carbons 2 and 3 will be up, and on carbon 4 it will be down. And there's our structure. Here is a ketose. So for a ketose, we have a generic structure that looks like this. We'll draw in our vertical bonds. I know that I'm going to have a CH2OH right here. That is carbon number 6, 5, 4, 3, 2. And we don't know for sure where carbon number 1 is yet. I'm going to look at the directions. The directions are telling me to draw the alpha anomer, which means that on my anomeric carbon, I want the OH group down. And that means, because the OH group is down, that means that the carbon, CH2OH, has to be up. So there's carbon number 1. Now we just have to figure out 3 and 4. 1, 2, there's 3 and there's 4. There's 3 and there's 4 when we turn this guy on its side to the right. Carbon number 3's OH group will be up. And carbon number 4's OH group will be down. And we have 3 more to practice. Here is another ketose. Here is the structure, generic structure of the ketose with the CH2OH in the left-hand corner. 6, 5, 4, 3, 2. And remember, with ketoses, we don't immediately know where carbon number 1 might be located. So this is what we're starting with. The instructions tell us we're drawing the beta anomer, so that means at the anomeric carbon, our OH group needs to be up in the sky. And because the OH group has to be sticking up, the CH2OH, carbon number 1, is going to be sticking down. So where do we draw the OHs on carbons 3 and 4? When we rotate this molecule on its side, carbon number 3's OH will be up, and same with carbon number 4. And there's what we get. So we have 2 more, and both of these are also aldoses. Let's get that general structure for the aldose drawn. And aldoses always have CH2OH up top. Let's put our carbon numbers in. 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6. This problem tells us we're drawing the alpha anomer. So at carbon number 1, we want the OH to be down. For carbons 2, 3, and 4, we have to imagine turning the molecule on its side. Where will the OHs go? Down, down, up. And last but not least, we have one more aldose. 6-membered ring. Carbon number 6 is up here on the top. 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6. What is this asking you to draw? Draw the beta anomer, so carbon number 1, OH is up. What about 2, 3, and 4? When you turn it on its side, 2 OH will be up. 3 and 4 OH will be down. There you go, you did it.